Chapter 1. What exactly is sound? Before we can understand the silence, we first have to understand sound itself. Right now, your ears are detecting invisible waves traveling through the air. Every word you hear is made from tiny vibrations. When someone speaks, their vocal cords vibrate. Those vibrations push nearby air molecules. Each molecule bumps into another, like falling dominoes. The energy moves through the air until it reaches your ears. Your brain transforms those vibrations into voices, music, or laughter. But here's the important part. Sound doesn't travel by itself. It needs something to carry it. Air, water, metal, glass, anything filled with particles. Remove those particles, and sound has nowhere to go. Imagine trying to create waves in an ocean without any water. Impossible. Sound works exactly the same way. And this simple rule changes everything once we leave Earth. Chapter 2. The vacuum of space. Space looks empty, but just how empty is it? Imagine taking every molecule of air inside this room and removing almost all of them, then removing even more until only a handful remain. That's still far denser than outer space. Between Earth and the Moon, there are only a few particles floating in every cubic centimeter between galaxies. There may be only a single atom across an area larger than your entire house. Scientists call this a vacuum, not completely empty, but so close that sound simply cannot survive. There are no chains of molecules to pass vibrations forwards. So when two asteroids collide, the impact creates enormous energy. Rocks explode, debris flies everywhere, shockwaves form inside the rocks themselves. But the moment those vibrations leave the surface, they disappear into the emptiness. No air, no medium, no sound. It's like shouting inside a dream, where your voice can never escape. Chapter 3. What would astronauts hear? Movies have taught us something very different. Massive explosions, spaceships roaring, laser blasts screaming across the stars. They make space sound louder than Earth. But reality is much stranger. If two astronauts floated a few meters apart, without radios, they couldn't hear each other. Even if one astronaut screamed with every ounce of strength, the other would hear nothing. Not because the scream wasn't loud, but because it never arrived. The vibrations remained trapped inside the astronaut's helmet. Only radio waves, which are electromagnetic, can travel through the vacuum. That's why astronauts rely entirely on communication systems. Without them, they would exist in complete silence, surrounded by infinite beauty, yet unable to hear a single whisper. Chapter 4. Is space really silent? Here's where things become fascinating. Space isn't truly silent. It simply doesn't produce sound the way humans hear it. The universe is alive with invisible waves. The sun constantly releases magnetic storms. Black holes shake space itself. Pulsars rotate hundreds of times every second. Galaxies collide. Stars explode. Every one of these events creates vibrations, but not sound waves. Instead, they generate electromagnetic waves, radio signals, X-rays, gamma rays, and gravitational waves. These waves travel effortlessly through the vacuum. Unlike sound, they don't need air. They travel through space itself. Scientists build giant telescopes capable of detecting these invisible signals. Then, they convert the data into frequencies humans can hear. Those haunting sounds you've heard from NASA. They're scientific translations. The universe wasn't speaking in sound. We simply taught ourselves how to listen. Chapter 5. The loudest sound ever. Ironically, the loudest event ever recorded happened in space. Around 240 million light-years away, a supermassive black hole erupted. The explosion released more energy than hundreds of millions of stars combined. Inside the surrounding gas cloud, scientists calculated that, if a human had been nearby, the sound would have exceeded 200 decibels. Far louder than a rocket launch. Powerful enough to destroy human hearing instantly. But here's the twist. Nobody heard it, because outside that gas cloud, the vacuum swallowed everything. The loudest sound in the known universe vanished into silence. A cosmic scream, with no ears to hear it. Chapter 6. Could humans ever hear space? What if we invented the perfect microphone, one sensitive enough to detect anything? Would we finally hear space? Unfortunately, no. A microphone also depends on vibrating particles. Without air, it has nothing to record. Instead, future technology may continue translating radio waves, magnetic fields, and gravitational ripples into sounds we can experience. Not because space suddenly became noisy, but because our understanding became deeper. Sometimes, the universe isn't silent. It's simply speaking, a language we've only just begun to understand. Silence has always fascinated humanity. We often associate it with emptiness, loneliness, nothingness. But the silence of space tells a different story. It reminds us that reality doesn't have to match our expectations. The universe isn't quiet because nothing is happening. It's quiet because its greatest conversations happen beyond the limits of human hearing. Every second, stars are born, galaxies collide, black holes twist the fabric of reality, invisible waves race across billions of light years. And somewhere, far beyond the edge of our imagination, the universe continues its endless symphony. Not one of sound, but of light, gravity, energy, and time. A symphony so vast that silence is simply how it feels to us. The universe is not silent. It is speaking in ways we're still learning to hear. If this documentary changed the way you think about the universe, don't forget to like the video, subscribe, and turn on notifications. Every week, we explore the biggest mysteries of space, science, and the unknown. Until next time, keep looking up, because every star has a story waiting to be discovered.